little
what
word
gives
bank
us
here.
the right enthalpy or entropy. And we kind of talked before, enthalpy, that's energy. You want to have money left over at the end of the reaction. That's the same thing as saying you've got energy left over at the end of the reaction. And entropy is that disorder. You want to go towards disorder. These are the things that give us the right kind of entropy and enthalpy. This is the first thing. Here's a second thing. And then here's a third thing. So one thing that will give us the right enthalpy and is the formation of the solid. That's mostly an enthalpy thing. You have to actually do it on a case-by-case basis to see for sure which one it's doing. Some textbooks will give a list of rules, so if you are Googling this afterwards and you're trying to figure it out, our textbook gives it as a chart. I like the chart. I think it's nice. I think it's less confusing than the rules, but we are going to show how to use the chart on the next page. So you're going to use a chart to check every product in the reaction to see if it's a solid or not. What's the AQ mean? It means that these two ions will dissolve in water. It means that those two ions will dissolve in water. It means that those two ions will dissolve in water, but this will not. You find out this information from the chart. So here's an example of how it kind of looks. They'll say, okay, we're talking about salts. By the way, these are ionic compounds. And so generally soluble, so we've got like chlorine, and then we have like exceptions over here. See how the chart works? We'll talk more about the chart on the next page, but the chart is one way for us to figure out what does and doesn't make something. But you'll notice that if I have a chlorine here and an Ag here, this is an exception to it being soluble. And that's why we would write down solid right here. But we're going to do even more with that information. I'm going to review these again on the next page. The second one is formation of water in the liquid phase. We're producing any gas, including water. Is just be any gas, including water, during the acid-base reaction. Notice that helps us with entropy and enthalpy. You don't have to completely understand that. I just want you to realize that there is a bigger picture to what we're saying. Strong acids and strong bases will break apart and make water. And in general chemistry too, you're going to want to memorize these. So I'm just giving you a heads up that some acids are strong and some bases are strong and everything else is weak. In Gen Chem 2, there's an entire chapter relating to the solubility of weak acids and bases. But this is all we're saying is that HCl, that's a strong acid. So I've got a little chart here. This is what you would be memorizing, Gen Chem 2. And here's strong bases. These are the alkali elements with OH, and then the lower alkalines with OH. Then there's also something funny that happens right here. We have these two guys that turn into a gas in water, and so does this one. And then everything else that doesn't break apart is over here on this right-hand side. So what this is saying is that this will break apart between those two guys. The NaOH will break apart like between those two guys because it's AQ. NaCl will break between the Na and the Cl because it's AQ. But water, and I know you're like, but water is in the water. Water stays stuck together. It doesn't break apart. So anytime you make water, it stays stuck together. It doesn't break apart. This guy, so as a little, well, here, I'll just review. So right here, like HCl, he was right here. So he's a strong acid. He breaks apart. And then our NaOH, right here, he's a strong base. He's our strong base, so he breaks apart. Then the NaCl, it's not an acid or a base. To be an acid, you got to have that H, and to be a base, you got to have that OH. The NaCl is something that's ionic, which would go back up to this first point, formation of solid. So we have a chart that combines this. I have a chart, at least, that combines this and this together in the same chart. So you don't have to worry about what it will and won't do. And then you'll notice here I've got H2CO3. And this is when it says it turns into a gas and water. And on this big chart I'm going to review this, where it shows it turning into a gas and water. But this is what it breaks apart into. This is an acid. And if you look, it's not any of the ones on this list. Acid is something that has an H on the front. Water doesn't ever break apart. And this is covalent. And covalent stuff doesn't break apart in water. Generally. The stuff we give you, it's not going to. And that's a gas anyway, so it's going out of the water. So just so you're aware, there's something called electron exchange. And it's in an oxidation reduction reaction. And this is another driving force, is if electrons want to move. There's an activity series chart that we would normally be teaching you about. It's in many textbooks to help with this. And in Gen Chem 2, you would actually use, this has an energy value and this has an energy value. And you would see if the electron would want to move and how much it would move. But guess what? Lucky for you guys, this whole section has been removed from this portion of general chemistry. And I'll show you which pages in the notes that also removes.